So, once the TP is balanced, you can work as usual. So, one example I am going to show you, and the remaining example you have to work, and we have to complete it today itself, because there is no time. Last week of February you will be having periodic 3, and March 8 you have final. So I have to complete the syllabus as early as possible and take one revision to clear your doubts and difficulties. So let me start with my example first. This is the example. We have started last day. But it is unbalanced. 3 origin of production center, Delhi, Hyderabad, Chennai, and 3 destination, Pune, Kolkata, Jaipur. The availabilities are 200, 150 and 100. So 450 available units and the demand is 500. Which means to complete the demand, extra units should be made available. And that is called dummy production center. And the dummy production center has 0 cost of shipment. $50 units. So wherever may be the allocation, it will never affect our original problem. This is the first step. This is the first step. Same way, if availability is more than the demand, you have to introduce a dummy destination. So now the transportation problem is balanced. We can do our work as usual. Apply northwest corner method. Find out the initial, check the optimum. So this one example, all the cases I will cover. And then you have to start question number 1 in the sheet.
Sir, sorry to interrupt, but which question sheet are you referring for this? Because this has not been shared with us yet.
Sheet 4. No, this question is not on your sheet. Your sheet has different questions.
Is it like an extra question? Something?
Yeah, it is an extra question. This is an extra question. So, I will be starting the work one after another. So, initially we used to make allocation matrix. All will be 0. If you recall the last class, If you recall the last class, we will make allocation matrix initially 0. So, the minimum cost will be matrix multiplication of cost matrix and allocation matrix. Be careful about your cell references. For me, K3 to M6 will be the cost matrix. R3 to T6 will be my allocation matrix. Product and the sum is my initial value. Then row total R3 to T3, R4 to T4, R5 to T5 in my spreadsheet. Dummy R6 to T6 are my row constraints. Similarly, column constraints yes. So that is not new. Row constraints and column constraints. So there are 4 plus 3, 7 constraints. One will be dummy.
Sir, can you zoom out your screen a little bit?
Yeah. Can you see? Is it visible?
Yes, sir.
So I have made the constraints. So I will be doing first northwest corner method. Those who were absent and those who didn't understand last time, they can have a repetition today. I am applying the northwest corner method on my allocation matrix. Here, starting from left top to right bottom allocation. So 150 demand and 200 available, 150 units I can give it to Pune. So from Hyderabad, Chennai, nothing to ship because Pune got all 150 units. Then 50 units are left that can be given to Kolkata. So Delhi warehouse is empty. And Kolkata want 150, 50 already we got, 100 you can ship from Hyderabad. No need of shipment from Chennai to Kolkata. Now Hyderabad left 50, Chennai has 100 and 50. So which of the place have shortage? Where will be the shortage?
Sir, in
Jaipur.
D3, Jaipur.
Jaipur. Jaipur is not getting 200 units, correct? How much Jaipur is getting?
150.
Yes. But our problem is correct. Northwest corner method gave me 8,950 will be the initial value. This is my initial value by the method. Any question? Initial value will be 8,950 and we want optimum, so we have to apply solver. Let us see what is the optimum answer. Data in the solver, reset all. Remember, every time you have to reset the solver box. Be careful in exam. So my objective cell will be minimum cost, function is minimum, allocation cells, constraint, all constraints are equal, so there is no problem. $7,750 will be my optimum. Allocations comes out to be different. देख लो. Allocation comes out to be different. Instead of Jaipur, 100 will be given from Chennai. And instead of 50, 150 will be given to Jaipur. But still, Jaipur has the shortage of 50 units. So the next batch production should be such. Jaipur should be preferred first to give the product. Because as per the demand only production starts. So till they use 150, the producer has to take care of 50 units to be produced and sent to Jaipur. Then the minimum transportation cost will increase. That depends on how much will be the transportation done. Is it at 21? Is it from Delhi? Is it from Hyderabad? Or is it from Chennai? So I made the transportation problem as a balanced transportation problem and I have done by northwest corner method and I got the answer. Now same way I can try for least cost entry method.
Sir?
Yes.
So in this case, if the availability is greater than the demand, then after the solver, the optimum solution will which we'll get, will it be 7,800 itself?
$7,750.
So this is when the demand is greater than the availability.
Then
Availability is greater than demand.
Yeah, you are talking about the another problem.
Yes, sir.
So that can be the cost. So I am doing here first the demand.
Okay, sir. Okay, sir.
Now least cost entry method I am applying. So among these, the least costs are zeros. So any zero I can give the allocation. Say I give Pune 50. So no more allocation to Kolkata from dummy. No more allocation to Jaipur from dummy. Now the minimum is 15. So top cell Pune require 100. So Pune got 150. Now the minimum is 15. that is Chennai to Kolkata and 100. And the next minimum is 20, 20. Any 20 you can take. I have taken this 20, of which 100 will be given. Another 50, obviously 50 here. And we have 150. Is it clear? So initially, the transportation cost will be 8,050. Let us verify what we will get by solver.
Excuse me, sir.
Yes.
Sir, why did we put the dummy of 50 units in under Pune rather than
Any
some other
zero I
city?
can choose. Any zero I can choose now.
Okay, sir. So we can choose any city, irrespective of the cost of sending it.
Any costs are 000.
Okay.
So
Because we
any
are not
one,
sending, so costs are zero.
yes, and any 10 you can choose for allocation.
Okay, sir. Thank you.
So now data solver solve it. Again comes out to be the answer 7750. This is the final allocation. That means Jaipur is going to have shortage for minimizing the TP cost. Jaipur will be having shortage to minimize the TP cost. But I have started giving to Pune. But optimum says Jaipur will be having the shortage. Next, 1. And for 1 we always talk about difference. So 15, 20 difference 5. 20, 25 difference 5. 15, 20 difference 5. 0, 0 difference 0. And here 15 and 25. 15 and 25. And 20 and sorry. 0 and 15. 15. 0 and 15. Again 15. 0 and 20. 20. So 0 is the minimum. In that direction, Kolkata has the allocation, or Jaipur can have allocation, or Pune can have allocation.
Sir, shouldn't we put it in the column of Jaipur, the one with the highest D value?
Higher?
Highest D value.
Highest D value? 20.
Yes, sir.
Yes.
Yes, sir.
But we want here minimize the transportation cost, na?
Right, sir. So, sir,
Even if I take minimum, still will do, because finally we are looking for solver. It will take care of.
sir, I don't agree, sir, because when I was studying about VAM, this D value is basically the opportunity cost. and we have to take the highest value, because if we don't put in Jaipur right now, that is Jaipur and Dummies intersection, if we don't put it right now, then basically means our cost will go up by 20 per unit. So hence we should go for the highest value and not the lowest value.
Okay. Now, what is the minimum total transportation cost?
Yes, sir.
What is the minimum total transportation cost? It is not one solution, correct?
Sir, it may or may not be VAM solution.
So in the manually, if you are going to do UV method on VAM, then you have to go for maximum to reduce the iteration.
Yes, sir.
But here we don't have any problems for solver.
Right, but sir, we should still follow the.
I understand that ultimately we are using the optimum solution as the answer, but like when solving by VAM, we should the rule is to use the maximum difference. That was my point also.
Manually.
Yeah, but the answer we are getting after solving with VAM, if we don't put in the highest difference, answer will be wrong. No?
Nothing wrong. It is not wrong. Without LCEM, without VAM, without northwest corner, even directly we can solve with the problem. Correct, na?
Sir, we agree on that.
Yes.
Sir, we agree on that. But VAM has a certain method which basically means it calculates the D value, which is the opportunity cost, and we want to put at A the lowest cost in the column where we see the highest opportunity cost. So
do it,
yes, sir, done, sir.
Even if it do, that is the initial total transportation.
I agree, sir.
Most of the times it gets equals to the optimum value, but if we do not put it in the highest, it won't get in the it won't be the optimum value at all. In the earlier step also we have seen that.
That will help you when you are going to do UV method. Iterations will reduce. That's all. Number of iterations to reach the optimum by VAM method will reduce. But here we don't have any iterations at all.
Okay, I have just one question. If in the exam you ask, find the value by VAM method. So if we do it in the highest difference, and if someone does it by the lowest difference, both the answers will differ. No?
Initially.
Initially it will differ. After finding the optimum value, the answer will be the same. But just by VAM, the answer will differ. That was my.
How many answers possible?
If someone takes highest value, it will get a different answer, and if someone gets lower value,
only two answers are there. Only two answers possible.
Two answers.
Suppose if highest difference will be repeated, then
we can go for any.
So then also VAM will change. Correct, na?
So there can be many answers of VAM.
Yes.
Okay.
But our optimum will never change. Why do we do solver? Solver we are going to do whichever may be the method. Even you can call your method. You give allocation as per your convenience. Go to solver, finally optimum. Just to tell you, these methods earlier days we do manually. Are you getting? UV method is very difficult to do on the board. If UV method, northwest corner method take 3 iterations, least cost entry method may take 2 iterations, sometimes VAM will give you immediately. For that point of view, it is a mathematical method.
So VAM can basically have different answers. The answer will be. Okay, got it.
Any answer possible for VAM.
Okay. Excuse me, sir. And what for other two, like northwest corner and...
One of you, only one. Yes, please.
In the exams, will we be only marked on the optimum value?
No. I can ask many questions than just VAM solution.
Okay. Okay. Thank you, sir.
I can ask many things. Now you see after this example, which one comes?
Okay, sir. Thank you.
This is just an algorithm I'm teaching you to reach the optimum. That's all. It is a systematic algorithm that I'm giving to you. Okay. So minimum is 0. Oh, let me take maximum. For those who explained, for them point of view, let me take maximum. Say 20. In that direction, minimum cost is 0. So Jaipur will be 50. Now again the difference will change because the row one last row has gone. Because no more allocation for Pune to Kolkata. So now the difference here 15 to 25, 20 to 25, 5, 15, 25. Here no difference. And here 15, 25. Next 15, 25. And the next difference is 1. So the maximum is 5. Which one I can take? Come on.
Any of us.
So any 5 you can choose. Everybody's answer may be different. Doesn't matter. So I will be choosing now, say this 5. And this 5, the minimum cost is this one, 15. So 100 units I can give. Again find the difference. So now Chennai and Dummy doesn't have the difference. 20 and 15, 5. 20 and 25, 5. 15 and, come on, which number here? What is the difference for Pune now?
15, sir.
Yes, 15. And the next 5. And the next 1. So which is the highest? 15. In that direction, these are the 2. Which is the minimum? Pune is the minimum. How many you can give? 150 from Delhi. So these differences will go. Now this is the difference 1. Next 20 and 25, 5. No more difference, no more difference. Here 20 and 21, 1. And 15 and 25. Again 5 is the highest. In that I have only 2 costs, 20 and 30. 20 and 25. So 20 is the minimum. There I can give 100. Obviously 50 will be here. And this 50 will be from Jaipur. So by taking this, my VAM also gives me minimum 8050. Apply the solver. Seven 750. So what I have done here, I just applied my usual procedure of northwest corner method, least cost entry method and VAM on the balanced transportation problem. The original problem was unbalanced transportation problem. By dummy, it is introduced and converted into balanced, and then do as usual. So remember, unbalanced transportation problem, whichever it may be, maybe dummy will be for production or dummy may be for destination. That depends on what is shortage. So two type of transportation problem you have seen. The given transportation problem can be either balanced or unbalanced. Now, third case. Take the same example.
Hello.
Listen carefully.
Actually.
Take the same example. I want to minimize the total transportation cost, but from O3, no shipment to D2. From O3, no shipment to D2. So I can apply northwest corner method, least cost entry method, WAM. Possibly, I can get allocation there, but I don't want. So this is conditional transportation problem. No matter the TP is balanced or unbalanced, this is a conditional TP. Okay, remember, I don't want to increase a number. What is to be done? Anyone?
Sorry, sir. Could you repeat that, please?
I am telling mathematics now. I don't want to increase a number. What is mathematics for it? A number x. I don't want to increase further. What is to be done? Array, a bucket has 100 pebbles. That is fixed. Capacity is full. I want to reduce it. What is to be done? What is to be done?
You want to remove the pebbles.
Remove. Minus, isn't it? Minus. Same way, I want to increase the minimum. What shall I do? If add it. So what is the meaning of addition and subtraction? Addition makes us to increase the number. Subtraction makes the number reduce. Correct now? Therefore, attentive please. In this particular problem, I want to minimize the transportation cost. But I don't want any transportation from O3 to D2. Mathematics says, therefore, give a very high number here. Will solver will give allocation there?
It would prefer not to.
No. Why? Because my objective is
To minimize cost.
correct. So if you any number 2000, 3000, कुछ भी हो, I gave 1500 because initially it is 15. So let it be 1500 to remember. करके देखो, नॉर्थ वेस्ट कॉर्नर अप्लाई करो, वाम करो, एलसीएम करो, allocation आ जाएगा, but solver will never give the allocation there. How many of you understood the logic?
Sir, I understood the logic. I just have one question. What if we wanted, what if our problem was such that there has to be at least one shipment from one supplier to one center?
Yes.
So
Yes.
if we have to give a condition that there must be, then what
Yes.
would you do?
Then you cannot do.
Sorry?
Then you cannot do number adjustment.
Yes, sir. So then what to do? Sir?
Because minimum you have to send it now.
Ali, what you may do is select all the quantities and you have to mention that all of them have to be greater than 0.
That goes without saying that, hey, all the
No, sir.
values are greater than 0.
No, sir, some values can be 0. As we are seeing in a lot of our solutions, a lot of values are 0.
If
What
you say,
Ali mentioned.
if you say all the values are greater than 0, then everywhere the allocation will come.
Yes, sir, and that is exactly what Ali has asked in his condition.
Yeah. If that is the case, there is no question of minimum cost. Whatever may be available, given.
No, sir. Just to be clear, I want minimum cost and at least one shipment from suppose Chennai to Kolkata.
That is what I say. X greater than 0. You do one allocation and see what you get. Everywhere allocation will be there. That minimum not necessarily will be the minimum of optimum. And why again at least? Because all these production centers have the same product now. What is the objective of TP? What is the objective of TP? They want to meet the demand and minimize the transportation cost. Then if you say X greater than 0 from every distances, everywhere you have to send minimum 1. Then what is the meaning of minimizing the transportation cost and meeting the demand? Why these numbers are different? 15, 20, 21, 20, 25. It all depends on the distance and convenience of transportation. Am I right? Chennai doesn't want to send Kolkata because that distributor might not have paid him last time ka shipment. Or trucks are not available for Chennai to Kolkata for the moment. Or Kolkata distributor says at present I don't want the product because still my warehouse has the product. So Chennai decides not to ship to Kolkata. Am I right? Is that clear?
Yes, sir. Yes, sir.
Conditional allocation is based on their past payment history, distribution history, or maybe transportation facilities are not available. Because if you want to send by road, trucks needed. If you want to send by rail, you need the wagon. If you want to send by flight, you need the cargo. If you want to send by ship, facilities and time. Therefore, we are talking balanced TP by introducing the number remaining all my algorithm same. Just solve it. How much it comes? How much is the minimum comes?
$8,600.
Oh. Naturally. So, whenever there will be a condition, accordingly, you have to do the problem. Suppose the given problem is profit problem. Imagine, it is a profit problem. And still Chennai doesn't want to transport to T2. So what number should I make? What is the logic?
Sorry, sir, could you repeat that, please?
The given data is profit per unit. And I want to maximize the transportation.
Sir, you'll change the solver to max and you'll minimize Chennai's cost to 0 or maybe 1 or something.
Not 0.
To negative.
Then 1, sir.
Correct.
Okay.
Give a least negative number. Never allocation comes there. Never allocation comes there. See, solve करके देखो. $10,800. Do we have allocation from Chennai to Kolkata?
No, sir.
So what you follow conditional allocations? What is the meaning of conditional allocation? There are restrictions. There are restrictions given. From origin to destination. And then do the transportation problem. That is what the cases I have shown to you. Now, actually what happened, when the conditions are there, in a transportation problem, can you have such many conditions? O3 doesn't want to shift to D2, O2 doesn't want to shift D3, O1 doesn't want to shift D1. Is it possible? Is
Yes,
it
sir.
possible?
Yes, sir.
If it is possible, then we don't want any method. We ourselves can get allocated according to the given conditions and then optimum, correct na? Say O1 to D1 doesn't want to transport the product. Then O2 doesn't want to transport to D3. Now, what to also say is I don't want to transport to Calcutta. Now, look at the table. Tell me what is to be done for allocation. Only survival cost are 20, 21, 22, 20, 20, 30. This 200 will be given these two places. 150 will be given here. 100 will be split into these two. And do the optimum by solver. But 3 by 3 table, plenty constraints, never possible. If that is the case, next time the business will run for the productions. Or they may change the distributors. So altogether what I say, whenever you have a transportation problem, generally one or two constraints will be there because he is experienced with the past. And how the production starts? How the production starts? That depends on the demand. So already you have given a promise to the distributor sending the product, then you have to send it. One or two cases the payment is not done or the truck is not available. If the regular truck is not available, side by truck you can use. On national highway, if you look, Bombay-Bangalore highway passing through our area, plenty trucks are going by road from south, from north. Anyhow, so as a class session point of view, you remember these two cases. Now, everybody should start question paper 1, example 1 in your sheet. After few minutes, I will show my answer. Start.
Sir, this sheet 4, I don't think it's been shared with us yet.
You have not received?
I'm not sure if others have.
It is sent last week.
We have received it, sir.
It is with you. Or copy the data from my screen and work. After 10 minutes, I will show my answer. By all the three methods, optimum has to be there. That much. Same optimum.
Sir, could you please go back to the Word file?
Everybody should work. For the coming class test, you will be having only operations research questions. Everybody should work. I will be
Sir, is the answer of the... Oh, sorry.
anybody got answer?
Sir, is the optimum cost 1505?
Yes. How much by northwest corner method?
Sir, I'm doing that.
Yeah.
Sir, I'm getting 1615.
Yes. What is optimum?
Optimum is same 1505.
Yes, continue.
Sir, I'm getting a higher value than them. I'm getting 1955.
Wrong.
Sir, they mentioned that there's a penalty cost on the dummy, so I've included that of 15, 13, and 12
Where you have used it?
in the dummy cost, sir. Because in the question it is written, if not satisfied, penalty cost for unsatisfied demand is 15, 13, and 12 per unit.
Where you are getting the allocation?
No, so in the cost, hence in the dummy costs, I've put 15, 13, and 12 in row 6. In row 6.
No.
Why not, sir?
0, 0, 0 will be the cost. After getting the allocation, check where you have the shortage, that penalty you have to use then.
But sir, if we are well aware of what our penalty is, shouldn't we include that and then try to reduce the cost?
If you use here 12, 13, 15, then you will get allocations now.
Yes, sir, I'm aware.
Suppose if you are using the allocation to, it is given 12, 15, 13, 12. Suppose.
Yes, 15, 13, 12, yes.
15, 13 and 12. Okay. Now let us see what we get.
No, sir, you've put it into the wrong matrix. You have to put it into the cost matrix, not in the quantity matrix.
Not the allocation matrix.
Yes, sir, we have to put it into the cost matrix.
Yes, X second. So here 15, 13 and 12. Let me put a different color for it. Now, let us solve it. My objective will be minimum. Allocation cells are these. एक मिनट. Repeat. Data, solver, cell minimum, change the variable cell, constraints add, equal to $1745. Which penalty is included now? Tell me.
Sir, we've taken dummy to Jaipur, but then sir, that should not count now, right? It should count in
It
the
is
next
counted
order, not now.
12 into 20. There is a shortage of 20 units in T3.
Jaipur, yes, sir, correct. No, sir, my point
So,
is,
12
this should not be counted now. It should be counted in the
Yes.
next order, right?
Yes.
Then why have we included it now? Then our cost should be
That's
15 or
what he
5.
said. That he told me, instead of writing 0, write penalties and check. Same answer comes. So what I have done was, I have not used any penalties. I have taken 0 itself. As usual. And I get my value. And I will check where is the minimum, where is the shortage. And that shortage, I will take care of the penalty multiple and add it. Plus, both comes out to be same way. So 1505 is my optimum. But $15.05 is my optimum. But what happened? D3 is getting shortage of 20. So 20 into 12 will be 240. Add it. It is addition of 1505 plus 240. So that comes afterwards. For solving the TP, by looking your algorithms, minimum is 1505. Now look where is the shortage. Multiply that by the penalty and add. Of course, what he said is the same way. But if I write here 15, 13, 12, then it may take as cost. This penalty. Or you have to mention here dummy with penalty. If the penalty is not mentioned, then what you are going to do? 0, 0, 0. That's what it's done. Okay, how many of you have completed? Any question now? One 615 by northwest corner method, least cost entry method 1525, WAM method 1675. But optimum is 1505, 1505, 1505. So have everybody has completed the question number 1? Let us go a bigger one. It is balanced. Find out the profit, maximum profit. First, O2 to D4 no shipment, find the maximum profit. O3 to D2 no shipment, find the maximum profit. Do it. Question number 2.
Sir, will you again repeat the first one where how we did about the
What?
yeah. So penalty problems.
Yes, I have done the distribution, correct now? What is my optimum? How much optimum you got?
1505, sir.
And which destination there is a shortage?
Sir, D3.
D3. How many units?
20.
And penalty per unit is 12 rupees. So 12 into 20, 240. So add
Yes.
240 to the value.
Okay, sir. Okay.
Is that clear?
Thanks. Yes, sir. Thank you.
So do the second question now.
Sir, can we put the value of infinity in the cost in the second question? I was asking I was asking back to my old days. Cost
I agree with you. Suppose if I put infinity symbol there, infinity multiplied by what will be writing as the answer? Infinity, correct now?
Yes, sir.
That is by manual working ray. Infinity का दूसरा नाम क्या है?
I don't know, sir.
Largest possible value.
Okay.
Suppose 15. I can give 1500. I can give 20,000. I can give 15 lakh. My answer will never change. So manually when you are working UV method etc. we write by infinity or big M we say. In the class we say big M method, capital M. So M is a large number or a least negative number in TP. So here we are working practical problem. So a large cost you give there.
Any theoretical large cost can be given by our mind.
You give by your own. Instead of 1500, you give 15,000 or give 50. Among others, largest, biggest number you give.
Okay, sir. So we are just merely replacing infinity by a large cost.
Large. Yes.
Okay, sir. Thank you, sir.
Infinity we are using for theoretical proofs. Any mathematics books, if you look, infinity is called as the largest number. Minus infinity is called as the least number. X-axis, Y-axis का कैसा है? Tell me. 0 to infinity line goes on extending, correct na?
Yes, sir. Right plus positive, left negative.
So there is never ending. Increase का tendency infinity. Decrease tendency is minus infinity. Clear now?
Yes, sir. Because I used to do manually. That is why I took infinity.
It happened. Okay, start second question, all of you. Remember, it is a profit problem, so you have to maximize.
The first one, you're getting 1990.
Yes.
Second subpart also, I think, is 1990.
Yes. Do we have allocation over to D4?
So allocation for both are different.
I am asking, is it O2 to D4 any allocation?
In the second subpart?
First part.
In the first subpart, there is no allocation.
In the second part, do we have allocation?
Still no allocation, sir.
Finished. Very good. Yes. Mohit Mishra.
Yes, sir.
How are you doing?
Yes, sir.
Akshat Sen. Akshat Sen. Govind Mittal.
Yes, sir.
Have you completed?
I have completed the first part, sir. I'm doing the other methods. I found the optimum.
Do it. Shubham Jain.
Yes, sir.
You have completed?
No, sir. Still doing.
Do.
So you called out my name?
Yes. Have you done?
Doing. In process. I didn't hear you.
Yes, do it. Complete both the part.
So can you repeat the answers of the last question of this question once? Like for the first
1990.
for both the cases.
Yes.
Sir, I am getting 3 different answers. So the first case, when there are no conditions, I'm getting 1990. The second case, that is for point 1, no shipment from O2 to D4. That is coming as 1660.
Yes, sir. Same answer. 1660, sir.
And the third one,
Because if we put 0.
yeah, and the third one I'm getting 1650.
Not possible. First one we don't want.
Yeah, exactly. So first one, when there are no conditions, I'm
We
getting
don't
1990.
want the conditional one. Our answer has to be conditional one.
Okay, so conditional one, sir, I'm getting 1660 and 1650.
Let me verify. Oh, sorry. So D1, D2, D4, D4. एक second. BL 3, 4, 5. Let me verify my answer. BB3 to BE5 and BL13 3 to BL5. Yes. So maximize the profit. First condition O2 to D4 will be minus 1100. Is it okay?
Yeah, sir. Okay.
Now let us solve it and check. Maximum variable allocations are these. $16 is equal to I am getting 1990. First answer. First answer is 1990 maximum profit. Let me do the next. Then also I am getting 1990. In both the cases, definitely no allocations are there from O2 to D4 and O3 to D2. But the maximum profit will be 1990. Anybody has doubt? Suppose O1 to D1 also no shipment, then check karo, answer again. Suppose O1 to D1 no shipment. Answer again 1990. No allocation there. So it take care of constraints when you are giving optimum. Okay. So we have seen here these different situations in TP. Initially, we have taken balanced transportation problem and we found the solution by northwest corner method, least cost entry method 1. If it is unbalanced, you have to make it balanced. Then apply all the methods once again. Next, no matter balanced or unbalanced, if there is a condition, accordingly you have to make the allocations. If the problem is minimization of the TP cost, that cell will be having highest positive number. If the problem is of maximization of the profit, then that cell will be having a least negative number. Are the different conditions we have learned in TP? Any question? And two problems also you have done. You can ask questions if any. Before I go for example 3.
Sir,
Yes.
I didn't understand the last question, sir, totally.
Huh?
Sir, I don't understand the last question, sir, actually, how it is solved. Because 1990 is my TP, but after that, how you allocate no shipment from O2 to D4, find my
O2 to D4, I don't want to ship.
Okay.
So make there a least negative number.
Like minus 1100.
1100 or minus 2000, minus 3000, kuch bhi ho.
And then I apply the solver. By solver, okay, sir?
And your answer will be still same.
1990, okay.
I mean to say, whenever you have a condition that from this origin to that origin we don't want to ship the product, accordingly you make allocation. Positive allocation for minimizing the TP, negative allocation if it is maximize the profit. But that is the logic I told mathematically.
Okay, sir. Got it.
Today itself practice once again. Anybody else? Anyone else? Okay. Now in question 3, I have covered all. TP is unbalanced. 4 by 5 matrix. So when you introduced dummy, it become again 5 by 5. You can find the optimum. You can find the conditional optimum. And this example you have to do it and come on Thursday class. On Thursday class, we are going to do something different. What is that difference? I will tell you. Yes. Attentive. I will not be introducing today, but you have to know what I say for the next class point of view. There are, look on the screen, 4 workers. Simple for introduction, so I take worker example. They have operated 4 machines in the past in the company to assemble the product. Attentive. "35 minutes worker 1 took to assemble a product in M1. 29 in M2, 26 M3, 25 M4. So each worker has different assembly time on 4 machines. It varies from worker to worker. Clear the data? So this is in minutes, time in minutes data. Find which machine to be given to worker 1, which other machine will be given to worker 2, which other machine will be given to worker 3 and worker 4. So that total completion time is minimum. Total completion time will be minimum. For example, worker 1, machine 1. Then worker 2 has how many choices?
3 machines, sir.
3. Say worker 2 will be on M2. Then worker 3 has how many choices?
2.
2. Say worker 3 will be for machine 4. So worker 4 has only
1 choice.
No. Suppose worker 1 is given machine 4. Worker 2 will get machine 1. Worker 3 will get machine 2. Worker 4 will give machine 3. So every permutation combination possible. Am I right?
Yes, sir.
Yes, sir.
Plenty possibilities of assigning the machine to the worker. Among this, which one will be the possible one? having minimum assignment problem, minimum completion time. Is it clear? Is it clear? Assign the machines to the worker. Assign different machines to the worker so that total completion time is minimum. Total completion time is minimum. But here there is not a marginal total like row total, column total. So we convert this problem into a TP problem. But if I convert this assignment problem into a TP problem, definitely there is no least cost entry method, northwest corner method or one.
No, sir, I disagree. They are available for us to use.
Tell me what is it?
Sir, you have your costs and you have.
We don't have cost here.
So we have time.
Time, yes.
And so time is a cost.
Ah.
So we can use any method that we want.
Ah. What is the marginal total?
No, sir, I will give you the answer, but I'm saying that they are available for our use.
If it is disagreed with me, tell me what is total of the rows, what is total of the columns?
Total of the rows 1 each and total of the columns 1 each.
What is 1 stand for?
Because only one worker will get assigned and only one machine will have one assignment to a worker.
Huh. So this is not availability and demand. This is we make it as a TP. Clear? So marginal totals are 1 each. Row total is 1, column total is 1. We mathematically convert it into TP. Is that clear? And already we know in TP without any northwest corner method, least cost entry method and one, I can get the optimum. We can get optimum. So this is not shipping cost. This is working time. And why do we have to double our work when this is not the shipping cost or minimization? But here also we can have minimum time, maximum product. That is, if 35 units are assembled in a week, 29 units are assembled in a week, 26 units are assembled in a week, 25 units are assembled in a week, then my problem will be maximize the number of units assembled. What is the assignment? So row totals and column totals are one that we make. So we say assignment problem also can be done through TP. And that is what we are going to work later on. Parallel to TP, even unbalanced assignment problem, if there suppose 3 workers are there and 4 machines. So assign the 3 workers to the machine such a way. Please close the microphone. Please close the microphone. Suppose if there are 3 workers W1, W2, W3 and 4 machines, then one machine will be idle. Find out which one. So it is unbalanced assignment problem. Or 4 workers are there and 3 machines. One worker will be idle. So everything will be repeating like TP, but in a different situation, assigning the work, assigning the task. So such is the work that we have to start again after completing the last question of sheet 4. And sheet 5 already I told them to mail you. So as soon as you get sheet 5, that first work we will be starting on sheet 5 on Thursday. So TP and assignment problem. So by next week, majority of the syllabus will get over. Then I am going to discuss with you something addition to each topic, like sensitivity analysis means what? Whether it is LPP, whether it is TP, whether it is AP, we have to learn what is called sensitivity analysis. So then only the topic will get completed. So meantime, you start practicing. Today is 9, 11 days are left. By 20th, I may complete the entire syllabus. And soon after that, end of the month, you will be having periodic test 3. Yes. Sarvi Agrawal,
Yes, sir.
do you follow what we have discussed today?
Yes, sir.
Please explain me in short.
So first we learned how to convert an unbalanced transportation problem into a balanced transportation problem. If demand is more than supply, we'll introduce a dummy and assign the cost 0, 0 in such a way that the TP becomes balanced one. Then we saw how if constraints are there, like if one distribution place doesn't want to transport it to one of the cities. So if we want to maximize profit, we'll introduce a number which is in negative so that no allocation comes there. And similarly, we did for minimizing cost, including such restrictions and everything.
Very good. Who is the one always disagree with my explanation? Neildar. Neildar, explain me today's work.
Sir, we had.
Let me see whether I agree with you or disagree. Come on.
We had TP problems in today's work, and the only difference in today was that we had some specific constraints. Like
Yes.
we did not want to give allocation to a certain cell, and there are multiple ways of doing this. You have mentioned that we should either increase the cost or decrease the profit. One more method is that you can just put a new constraint that on that cell you can just put a constraint equal to 0. And then the last problem was assignment problem, which is
what is the difference between balanced and unbalanced TP?
Sir, in balanced and unbalanced, so the main problem is there's a demand supply, they're not equal basically. So how you solve that is by creating a dummy.
Yes. And what is the cost assigned to dummy?
So cost assigned to dummy is usually 0 on default unless there's a penalty mentioned.
Okay. Further, come on.
Then we had assignment problem, which you mentioned at the end, where everything works in integers, and like one gets assigned to each and every. So there's only one number in each row and each column.
Yes.
So
what that one stands for?
So it stands for assignment. So basically, if we think about it, there are 4 question papers or 4 answer papers, and there are 4 students. So you have to give one to exactly one. You can't give the same question paper to two people. So that is one way of understanding.
But all the question papers are same.
Yes. But I'm just giving an example, sir.
All the workers are not same. All the machines are not same.
Yes, sir, and they have varying times that they require, or varying productivities with each of them. So you want to find out what is the best way of assigning.
Okay, Okay. Further, anything else can you add?
No, sir. I just had one disagreement with you on the assignment. I just said that we can use VAM and we can use least cost method and we can use all those methods. It is applicable. I'm not saying it is effective. I'm just saying it's applicable.
Then okay. So you do that with the problem and tell me
No,
what
sir.
you think.
So that is the difference, sir. The difference is that I'm just saying it's available. I'm not saying that we should use it.
Actually, what's happening there is, if you use northwest corner method, start from top. There is no multiple come. Either you allocation is only one. है ना? Suppose worker 1 will be assigned to machine 1. So what you do there? Give 1. Remaining all 0. But if you least cost entry method, you will take the minimum, give there 1. Finally, it comes out to be nothing but your optimum only. Check करके देखो, check करके देखो.
Yes, sir. Which is exactly what I'm saying, sir. That is exactly my point.
Okay, ठीक है, accepted. All right. So, in all the problems of TP, we have covered mainly two cases, balanced and unbalanced TP. Number 2, conditional constraints. No matter what, we can apply all the 3 methods and optimize. And Thursday, everyone is coming preparing with example 3, and then we have to go to assignment problem. And start preparing well for the periodic 3. That will help me to teach you sensitive analysis in a best way. Okay? Any other question? Ayush? Ayush? Ayush Bhushal? Amit Ingle?
Yes, sir.
Yes, sir.
Yeah. Is it clear today's work?
Yes, sir.
Yes, sir.
You have any doubt on this algorithms of solver?
Sir.
Ayush?
No, sir.
Okay. Amit Ingle?
Yes, sir.
Do you follow the work that I have done?
Yes, sir.
So you are preparing for next class by solving the example 3.
Yes, sir.
Namrata Gaur? Namrata? Namrata Gaur? Nikhil Agarwal?
Yes, sir.
Do you follow completely TP problems now?
Yes, sir.
Okay. So do the question 3 and prepare and come for Thursday's class.
Okay, sir.
Okay. So any question to anybody?
Sir, have you checked our copies?
Periodic 3. Periodic 2.
Yeah.
It's going on.
That's okay.
Even if I ask simple questions, I don't know what the students have done. Sometimes I feel pity. After giving so much algorithms, question sheet, I typed the algorithms. Okay, remember, final test, more weightage will be on testing of hypothesis. Keep in the mind. Because for testing of hypothesis, I have not added any class test. I will tell you after completion of the syllabus the pattern. It is not MCQ only. It is actual question paper. Definitely not MCQ. So the final exam will be theory as well as coding of our Excel sheet. Everything you have to know. Of course, you can work in R and Excel. Solver can be used only for operation research question. R can be used for statistics. Even or also can be solved by R, but so many coding we have to do. So that is lengthy. So start preparing. There is no time left. Only a month is left for final. So Thursday class, I will be doing introduction of assignment problem. Keep in the mind. Okay. Goodbye. Have a good day.
Thank you, sir. Have a good day, sir. Bye.
Thank you, sir.
Thank you, sir.